Yes.
Good evening student, welcome to Kukureja classes. Today in the chapter of electricity, we will learn about the series circuits, parallel circuits, resistance, electric power and electrical energy. So to start with, we have a few questions like why does one fused bulb in decorative light chain makes all the bulbs go off? The answer is that because in the light chain, in decorative light chain, the bulbs are connected in a series end to end and it is controlled by a single switch. So whenever any bulb get fused, so it breaks the circuit and makes other bulbs go off. The second question is why does your fan keep running even if a bulb in another room fuses? Because in domestic wiring we use parallel circuit in which we have a separate switches for each and every device in the appliance in the home. So whenever any appliance get fused or any bulb get fused, the other circuit remains working. So this we will study in this lesson. So before studying the series circuits and parallel circuits, we should have the knowledge of Ohm's law. We know that as per Ohm's law, the current flowing through a conductor is directly proportional to the potential difference across the ends of the conductor. So we can say I is directly proportional to V, or we can V is directly proportional to I. So when you increase the potential difference across the conductor, the I increases, as well as when you decrease the potential difference across the conductor, current in the conductor decreases. So this way they work, and the ratio of voltage and current is the constant which we call resistance. The unit of resistance is ohm. So resistance, you know that the current in the conductor is due to flow of electrons. When the current flows in the conductor, the electrons you could say collides with other atoms or ions present in the conductor and cause opposition to the flow of current. This opposition is called the resistance. Resistance opposes the flow of current in the conductor. The resistance of the circuit or the resistance of the conductor or the substance depend upon the length of the conductor, thickness of the substance, temperature of the substance, and the you can say material of the substance. On these factors, resistance of the substance depends. Moreover, as per Ohm's law, you can say that the resistance is in current. Resistance is inversely proportional to the current. So when the resistance in the circuit is increased, the current decreases. So and similarly, when we decrease the resistance in the circuit conductor, the current in the conductor increases. So both are inversely related. So we know there are conductors, resistors, and insulators. You have heard these words. In the resistors, you know that they have a moderate resistance to the flow of current, like nichrome, constant, and these are the resistors we use in the heating appliances. And we have a conductors like copper, silver, aluminum, which have a low resistance and offer conduct the electricity in them. Then there are insulator which have an infinite resistance to the flow of current, like bakelite and rubber. These are the examples of the insulators. So before proceeding further, we have as I have told you that the resistance of the conductor depends upon the length of the conductor, and resistance is directly proportional to the length of the conductor. Resistance of the conductor or substance is inversely proportional to the thickness of the substance or area of cross section of the conductor. And so when we change the you can say that proportional signs with the constant, there is a rho which is called resistivity. So resistivity is and we also called it as a specific resistance. So specific resistance is numerically equal to the resistance of the conductor of the